So we had an image and we saved it in lots of different file formats so we could have a look at the different sizes. And you can see here's that image. We saved it as a GIF file, JPEG file, BMP file. And if you look in the fourth column, you can see that the size of the files varies depending upon the file type that we chose. Now, looking at the figures for the size, which is in the fourth column here, you can see there's a very obvious reason why we don't really use BMP files over the internet. It's a very large file format. You can see why GIF, JPEG and PNG files are taken off over the internet. The wider question here is, how do we measure sizes in computing? And you can see that those are measured in kilobytes. If you look at the measure that comes up after the number in the size column. Well, what is a kilobyte? Well, we can interpret a kilobyte for the moment to be one letter or one character in size. So for example, if we look at this phrase here, hello there, you can see we've got a whole collection of characters, of letters, and you could count them up, and you can see that we've got 10 letters there, 10 characters. But of course, that would actually be 11 bytes rather than 10. I'll leave you just to think about that for a second, because of course, if you look in the middle, you can see we've got a space, and we do actually need a character which is a space character. So that would be 11 bytes in size. Now, originally, kilo in computing meant 1024, but more recently it's taken to mean 1000, and there's a big argument about should it be 1024, should it be about 1000. So often people say about 1000. If you want to read up on that, then you can find out what a kibibyte is. I'm just going to say it's about 1000 in these in the slides that we're talking about here. So as an example, how many kilobytes would be required to store the information in an average paperback book? So if you were to try and work that out, then you might go, okay, let's visualize a book. We know that there are a number of letters across, a number of lines down, and a number of pages. So what I'd like to do is just pause the video for a second and try and estimate how many of those there would be. How many letters across there would be in an average paperback book, how many lines down, and how many pages there would be. So just have a think about the numbers that you would come up with. So here are some example numbers. You know, we could say, well, it's about 50 to 60 characters across, about 25 lines down, and about 300 pages. And if you multiply those all together, you get 1,250 characters per page. That's 50 times 25. And then we multiply it by the 300, and that would give you sort of 375,000 characters in a book. So 375,000 characters, that would be 375,000 bytes. And if we divide that by 1,000, because that's what a kilo means, 375,000 bytes would be 375 kilobytes. Now, bytes is a standard measure used in computing all the time, used to measure file sizes, so it doesn't matter whether you're using Excel, images, web pages, music files or video files. All of these are going to be measured in bytes. We know that books are quite small. You know, we saw a figure of about 300,000 bytes. Obviously, when it comes to storing music and video and larger files, there are other measures that we can use. And that typically means something like this. We use megabytes, which means 1,000,000. We use gigabytes, which is 1,000 million bytes. And often that's abbreviated in ways that I'm sure you're familiar with, like 2 MB, 5 MB, 20 GB. 2 megabytes, 5 megabytes, 20 gigabytes. And the most common place that you probably experience this is on a flash pen drive, for example. So, you know, those are standard measures for the things like 2 gigabytes, 8 gigabytes, things like that. So, quick example here. Say you had a 2 gigabyte memory flash drive. How many paperback books would fit on there? So you could do a quick calculation. You could go 2 1,000 million divided by the number that we had earlier on. So if you just pause the video, you could just work that out and see what you come up with for a figure for how many books could we store on this flash drive. So if we do the maths, we just divide one by the other, we could store an amazing number of books on here. We could store 5,000 books. Now, when it comes to music files, those are typically much bigger. So, you could get a music file which is like 60 megabytes in size. When it comes to movie files are typically, again, the next size up and the next scale up. Typically with movie files, you're typically talking in gigabytes. So if you were to download the latest blockbuster, then it could be like a 2 gigabyte file, for example, if it had been compressed. Flash drives plug into USB ports. And USB ports, when they came into computing, were revolutionary, because before that point, we used to have different connections for all the different devices that we used to plug in. And often the connections used to be proprietary to the device. So a printer would plug in a particular socket, a camera would plug into a different kind of socket. So USB was revolutionary when it came in, and it certainly helped make things a lot easier when you want to plug devices in. The current standard for these ports is USB-C, a much smaller port and a much smaller sort of socket, and it's reversible, and it can also carry power. So often laptops nowadays, they'll come with some USB ports, and you can plug devices into those, and you can also plug in your power adapter as well. Often you'll see those on laptops and mobile. In the old days, we used to use floppy drives, and they were tiny, so you could fit 1.44 megabytes on these. So the days of students passing floppy drives around and having multiple floppies have thankfully gone away. But when it comes to flash drives, it's quite interesting. What I've been doing here is I've just been gradually, over the last few years, just writing down every year the prices of flash drives. And you can see how the capacity has increased and how the price has dramatically dropped. So you can easily be wandering around with terabytes of storage in your pocket. I will just say, just be slightly careful of flash drives. It doesn't matter whether they're flash drives or flash memory or hard disks. They do go wrong. So make sure you back your work up. And there's plenty of easy ways to back your work up now, including cloud services. You've probably got some free cloud space with your internet provider. You get OneDrive with your university account, or even a Box account. Often they talk about sort of having backups in using a 3-2-1 system. So that's 3 backups on 2 different media in more than one location. So you could use it to save information on your computer, duplicate it onto a flash drive, and make sure you've got it saved in the cloud as well. And of course, because it's cheap, often in many cases it's free. Nowadays, we don't accept that, my device crashed as an excuse for losing work. You should be saving your work into the cloud automatically to make sure you've got everything backed up.